have management and ownership that cares enough for the station to buy us the best equipment for us to use in computer modeling and graphics machines and our own Doppler radar.
We're the only company that owns and operates a Doppler radar in Texoma.
This allows us to identify low-level circulations where we might see tornadoes forming, also identify outflow boundaries where gusty wind might come out of the storm.
We're able to see the storms in more detail, and we can even change those variables with the radar to look into more perspectives with the storm.
Doppler effect was named after a guy named Doppler, and he observed that a train coming down a track would have one sound as the whistle approached. Then as the train passed by, the pitch of the whistle would change. This is called the Doppler effect.
The difference between Doppler radar and the conventional radar is that Doppler radar sends out a pulse of energy, sort of like a laser beam that goes straight out and detects a part of precipitation, if you will. It reflects it back.
It is measuring the velocity of the storm approaching or leaving the radar.
The benefit of having our own Doppler radar is that we can see things that the other radar sites that surround Texoma can't see.
A lot more information has developed in the Channel 12 Weather Center because we use that Doppler radar.
A lot of folks have asked me over the years, well, why do we care that you have a Doppler? Weather Service has good Dopplers, but they're 70, 80 miles away. Now, unfortunately, the radar beam travels line of sight, straight, and the Earth curves, so the farther away the radar beam gets, the higher up into a storm it's going to shoot.
If we try and use someone else's radar that is out of our viewing area, it can only scan straight. It can't take the curve of the Earth. So if we try and go a couple hundred miles, that scan angle is going to be at almost 30,000 feet, where really we need to be looking at the lower levels of the system, because that is where the more heavier concentration and focus needs to be during a given severe situation.
The benefit of this is that the most severe weather obviously takes place closer to the surface, where tornadoes form, where downdraft winds take place, and where hail comes down. And we're able to see the intensity of the precipitation, whether there's hail, and also be able to see if there's circulation and rotation, which we associate with tornadoes and severe weather.
Also, we can see wind gusts, we can see outflow boundaries, and those microbursts as well as bow echoes, which are hard to detect from some of the other radars that are much further away.
A really good case of this was Lone Grove in 2009. We were tracking that storm live. We were the first one to report it on the ground. We had a very well-defined hook on that storm. The National Weather Service radar 80 miles away also indicated a dangerous circulation, but it did not have a hook. It just was too far away to have that definition in the lower levels.
Every piece of information is very important to us, and we try to forecast the best that we can with that given information. The more accurate, the more information that we can get, the accurate the forecast can be that we can deliver to our viewers.
I like to say that weather forecasting is an information soup. There's a lot of stuff in there. We have a lot of information that comes in over the internet. People talk about the models all the time. These are just basically complex mathematical programs that try to forecast the weather.
Another data system that we use is Weather Central, and it provides us composite radars from both Oklahoma City, the National Weather Service radar, Tulsa's radar, and Fort Worth's radar, and Shreveport's radar. We're able to go ahead and use that radar to reconfirm what we're seeing on our own Doppler radar here.
And we take that data in conjunction with what we see on Doppler 12 Live, put it into a ball, crunch it in our mind, and come up with a valuable forecast that is very important to not only us, but hopefully to you.
Science is not perfect. It's a constant challenge every day to try to pick out what's going to happen with the weather, and we consider it a personal challenge to be right. We want to be right as often as possible to help our viewers. I mean, people are planning their lives around the weather, so we don't take that responsibility lightly.
To get that forecast, that's very important not only to me, but to you, so you can plan how to dress for the day and what to expect over the next several days.
So if we can make the weather understandable, then we can go ahead and make you more confident to share that weather forecast with somebody else.
We want to deliver to our viewers the best forecast possible, especially for more severe situations.
Because of that, I think that makes me want to try really hard to be right.
Our job is to share the weather in a way that you're better prepared to deal with the weather that's going to be coming.